Okay, first problem here is an involved system of three equations and three unknowns. So I am going to use my calculating device to figure out what this is. Second matrix, and I'm going to edit. I have something else in matrix A, so let's do B. I need a 3 by 4 matrix, and in that 3 by 4 matrix, the entries will be 2, -1, 7, -10, 3, 2, -4, 17, 6, -5, 1, -20. And then I will perform the matrix math called row reduced echelon form of the matrix B. And it appears as though the answers are 1, 5, -1. So the solution here is 1, 5, -1 using row reduced echelon form in a matrix, but you could use substitution or elimination or I guess guess and check, although I would not recommend. Okay, second problem is find a fourth degree polynomial that has roots of 1 and -2 and 1 plus I. So f of x will be equal to sum a multiplied by x minus 1 multiplied by x plus 2 multiplied by some quadratic that has 1 plus I as a root. And I'm going to assume it's a real valued polynomial, real coefficients on the polynomial. So I need to figure out that quadratic. So recall the way that we find that quadratic is we can pretend that x equals 1 plus I, which would mean that x minus 1 would be equal to I, so that x squared minus 2x plus 1 would be equal to -1 by squaring both sides, and x squared minus 2x plus 2 is equal to 0. So in other words, this is a quadratic polynomial that equals 0 when x equals 1 plus I. That means that is an acceptable quadratic, minus 2x plus 2. And of course, by the complex conjugate theorem, root theorem, that means 1 plus I means 1 minus I comes along for the ride as well. Now we had extra information here that said 0, -5 is my y-intercept. So f of 0 is a multiplied by -1 multiplied by 2 multiplied by 2. 2 times 2 is 4, so this is -4a, and that's supposed to be equal to -5. That's supposed to be equal to -5. So therefore, it's like I'm setting it equal to -5, a must be equal to 5/4. So the final answer, when all is told on this problem, would be f of x equals 5/4 x minus 1, x plus 2, and then this x squared minus 2x plus 2. Okay, third problem. Sketch a graph of this rational function and then use it to find a particular limit. Okay, so this function is x minus 3, x plus 2 over x plus 2, x minus 1. So get some nice reduction with the x plus 2's, which is going to create a hole located at -2, comma, whatever you get when you replace the x with the -2. So -2 minus 3 is -5. -2 minus 1 is -3. So it'll have a hole at -2, 5/3. Attempting to draw the graph, we have a vertical asymptote at x equals 1. Because it's x minus 3 over x minus 1 and the top and the bottom are of the same degree, that means we also have a horizontal asymptote at y equals 1. There is an x-intercept located at 3, because that's when the numerator would be equal to 0. So 1, 2, 3. That indicates that my curve is probably down here. And then over on the other side, I have a y-intercept. When I plug in 0, -6 over -2 is positive 3, which indicates my curve is coming above like this. Don't forget, there was a hole located at -2, 5/3. So therefore, when we answer the last part of the problem, it says, use this graph to find this limit. As I approach -2 from either the left or from the right, I approach the hole. And so the answer to the limit, as x approaches -2 of f of x, is going to be equal to what that hole's y coordinate is, which is 5/3. And that's the answer to the limit part of the problem. And then the last problem from this page is given that the terminal side of an angle goes through -2, -4, so left 2 down 4, left 2 down 4. Find the trigonometric values of all of the angle, all the trigonometric values of the angle. Okay, 2 squared is 4, 4 squared is 16, so this side is radical 20, also known as 2 rad 5. So when I'm getting ready to do the trigonometry, where I don't really care about similar triangles, or all similar triangles have the same trig values, I'm going to think of this side as rad 5 by dividing by 2, think of this side as -1, and think of this side as -2. It's the same angle, it's just kind of been halved, so that way everything is in reduced form. And the reason I like to do that is because then I can say that, well, the sine of theta is the opposite over the hypotenuse, -2 over rad 5. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent, which is 2. And then our cosecant theta becomes the reciprocal, so -rad 5 over 2. The secant of theta, reciprocal, -rad 5. And the cotangent of theta is the reciprocal of 2, which is 1/2.